106, I'm excited to go over these problems with us because we got to know a couple things. We got to know how to condense, and then we have to know how to solve. What they're looking for is, if this was a calculator problem, it'd be pretty easy. I would plug in what f of x equals, I'd plug in what g of x equals, and then I want to know where do they actually intersect. So if I draw a quick picture here, and this, by the way, does not illustrate this, but if I drew a quick picture and I said, okay, this is what f looks like, and I said, all right, this is what g looks like. Again, I'm just giving you an example. What they're looking for is, if they intersect, they're going to intersect at a point, and that point is going to have an x and a y value. This says what is the x value of where they intersect. So what we're going to do is we're going to set what f of x equals to what g of x equals to. So let's do that. We have log base 10 of x plus 3. Now, as I do this, because we've done so many problems in a row, we need to condense this. Notice we have the same log base, so division is going to turn into subtraction is going to turn into division. We can only do this when they have the same log base. So whatever comes first is on top, and on the bottom is simply x. So I've condensed f of x, and I'm going to set it equal to what g of x equals. Okay, now you're thinking, like, what do I do here? So let me go back, and I want to just give you another example. If I said this to you, let's do an easy one. If I said this to you, and I said, okay, we need to solve for x, what would we do? Well, we could write this in exponential form. The base in this problem is 3. We're going to jump to whatever's on the opposite side of the equal sign, and that becomes the exponent. And then what's ever directly behind the base is what it equals. So in this case, I know that x is 9. Now, how does that relate to what we're doing? We're going to write this in exponential form. So 10 is my base. Okay, 10 is my base. I'm going to raise it to whatever's on the opposite side, which is 1, and I'm going to set it equal to x plus 3 over x. Thumbs up or thumbs down if that makes sense to you right now. Okay, so I know 10 to the first is simply 10, so let me give myself some space. So I have 10 equals x plus 3 over x, and I'm going to put a 1 on the bottom of the 10. We can put 1 on the bottom of any numerical value. It's not going to change that. Okay, next I'm going to cross multiply. 10 times x is 10x, and then I know 1 times the quantity x plus 3 is simply going to be 1x plus 3 equals 10x. And now I'm quickly going to solve here. So I'm subtracting x, and I end up with 9x equals 3. Be very careful here. A lot of students in the past would say this answer is 3. 3 over 9 actually is 1/3. And so what you also need to do is you need to remember this. When we look at the log, we see 3 different places where we're going to see values, or we're going to see variables. There's the base, the answer behind it, and then this turns into the exponent if we write it in exponential form. These two right here, can never be negative. Did everybody hear that? They can never be negative. So we're going to take a quick look here. If I take 1/3 and plug it in, all I have to know is 1/3 plus 3, is that a negative number? We're good, it's not exponential. If I plug in 1/3 here, it's not a negative number. So the correct answer is B.